Another activity, there was one of the requests during these loops with feedback loops that we needed example of classroom materials that the teachers could also do with their students, and that you could let them work on it as if they were students, so that they could copy this kind of way of dealing with using a resource with their own students. One was about chocolate production, and well, there was a lot of information is given. The main idea is to start a discussion on students' chocolate consumption and to what extent they are willing or familiar with fair trade chocolate and willing to buy it. Then using a kind of think, pair, share in where they could reflect on what kind of information they would need to make argumented choices, and then really go on the internet and try to collect this information, and at the end again reflect on what is going on there. And initially you wouldn't say it has much to do with mathematics, but when you see what kind of information is given, you need to really deal with numbers, trying to interpret it and do calculations with it, and it's not that easy to solve it when you don't do any calculation at all. The same one was about plastic soup. This is even turned into a kind of booklet we made with classroom materials. And it's about what amount of waste can be saved in household, in our town or in our school. Teachers can phrase it differently if we all try to buy unpackaged food. And that's, and in the Netherlands, I don't think you see it much often, but in Germany it's really popular, the markets where you can buy food without packages. So you need to bring your bags yourself and they put it there, and it's a new kind of culture. So what can you save? And also here was a remark about can you make that visible, what you can save? So what kind of area and how high is the volume of plastic that you can save? Well, German teachers' responses, there were many different kind of responses, but of course one of them said, well, I'm not sure whether this is mathematics, it's only about calculations, and I would not use it. While others reacted, well, there is some statistics in it, and even some measurement and geometry, and also, well, much more positive also about the importance of these kind of contexts using it. And well, I liked this context because even last week when the news was that China banned plastic bags, there was also something about the country's largest rubbish dump with a size of around 100 football fields. And I thought, that's not so big for a largest thing in China. Normally largest things in China are really big, and 100 football fields. But it is already full 25 years ahead of schedule. Well, trying to imagine 100 football fields, is that really big? And this, what does it mean? And compare that to what's happening in your town. That's, I think, really nice mathematics to think of these kind of sizes. Okay. So what we in the project found is that partners also in the feedback cycles, some of them wanted a real strong focus with general education and see the mathematics and the science that involved there, while others emphasized the importance of contexts that are relevant for society, critical thinking. So there were really differences in what teachers and partners appreciated. Also the request for ready-to-use materials that were not too big, large problems, but that you can do during a lesson. And suggestions of how to adjust the module to different target groups. There were, in some countries, they worked with initial teacher education, so teachers just learning to teach, while others were very experienced teachers. And there was one remark about the different contexts in the two modules, the one more on active citizenship and the other really on differences in culture. Okay, so with these modules, they were optimized and we set up a study, and there was a questionnaire for teachers about their also beliefs about IBL, to use it, and their self-efficacy to use IBL for taking the opportunity of diversity. And here you see the numbers that were involved, of the teachers. And in the end we had, well, not too much, but a rather sufficient sample of teachers joining and all doing the course. And here you see the differences in age, so the average age and average year of experience, to have an idea that in Cyprus and Spain there were real experienced teachers, also a bit older, while in the Netherlands on average not too many experience. And so, well, to get an overview of what kind of teachers were involved in these courses, there also were of course other characteristics. And well, we found some effect in their beliefs, but a very little effect in the beliefs about using IBL for addressing diversity, about using context in the teaching, and especially then about cultural diversity and how to address that. So is that, do I need to address it in my classroom? Is it really an issue, or is it not really an issue? And here we found hardly, not really an effect there. And especially also in the Netherlands, the teachers that were involved in our course didn't think there was really a problem there. And so that you couldn't see in the overview of what kind of teachers we had, we didn't have any teachers of real city schools. So we mainly had teachers that were in the Youth Talent Network, so that were not in the city schools, and teachers that were here that had already the second degree and wanted to come here for the first degree, and also of the area around and not the city. Yeah.
What's the scale of 1 to 4?
It was.
What is it?
Yeah, so you can have disagree to agree, and there were 4 Likert scale, 4-point Likert scale.
2.5 is neutral?
Yeah, probably, yeah. It's in between 2 and 3. Yeah. But on self-efficacy, we had a bit better results. There, well, using IBL for addressing diversity and using the context, there, well, really it was at least nice to see that we managed to achieve this. Although I'm not sure about what we really achieved in practice. There's now one of our master students that's interviewing a few of the case study teachers that were in the Dutch sample, and also is reproducing the same parts of the same questionnaire. And there, well, already she's not finished yet, but we see that only 1 or 2 still use the same kind of problems, and others, well, hardly anymore. Okay, so what we conclude from this, we have a kind of proof of principle, how to address diversity using IBL with a PD course. Teachers become aware of and acknowledge how to address diversity in science and mathematics teacher. See it as an opportunity and don't label too quickly. So, little positive result here. And we were able to, it's also a kind of result, to extend this modeling cycle to include also the importance of, well, when you try to simplify a model of a situation, that the importance is that you are able to collect information and to evaluate the resource and the information you receive, and also the discussion of contradicting results, and take into account their ethical and social, cultural and economic aspects. So enrich this model with elements that are related to culture and diversity. Good, that was the MASDIV project. So now about the Myriad project, that was in particularly focused on mathematics teaching and how to implement inquiry according to a kind of scenario inspired by TDS, the theory of didactic situations. And the research questions are: what are characteristics of tasks that support students in developing ideas that are rich and varied enough to provide access to intended mathematical knowledge, so that the inquiry they are doing provides a kind of ground from which you can build the formal mathematics. So also remember this definition of Marshall really connects to this. And how can teachers be supported for implementing these tasks was the second question. And the hypothesis was that RME, ideas from RME and TDS could be helpful here. Okay, in a nutshell. So these slides are designed by Rogier. Nice animations to show the part of the main idea of this theory of didactic situations. Because this theory, I think it's not really familiar, or not many of us are familiar with it. And I think one of the reasons for that is that it uses quite a specific vocabulary, which doesn't make it easy accessible. And these animations are meant to have a kind of idea of this vocabulary. So one important idea is that knowledge, what we count as knowledge, is often the knowledge that is institutional in school, or in the institution determines what we see as the important knowledge. So they talk about institutional knowledge. And the idea is that in traditional education, the teacher knows the institutional knowledge, and the task for the teacher is try to transfer it to the student. But in this theory of didactic situations, of course we also have institutional knowledge, but here the main goal is not to transfer to the students, but to create a milieu. A milieu is a kind of learning environment. Please correct me as soon as and this learning environment needs to be transferred to the student. So this can be a rich problem or a situation where the students need to work. And while dealing with this learning environment, the student is acting on its own. So that's during the inquiry, or during this acting, is what they call a didactical situation, because when the students are working on a problem, the teacher does not intervene. So this is adidactical. And the teacher looks at that process and is responsible for it. And the didactical situation is oriented around it. And the teacher only observes students and student strategies when the students are working on a problem within that milieu. The students in groups or individual create personal knowledge. And the idea is that when they have created the personal knowledge, there is a phase where they exchange and they formulate what they have found, and that there is a kind of comparison about what is found, and that you can validate each other's strategies and see that some are very, solutions might be very case-based, while others are more general and already using a bit more general language or another kind of reasoning. And the milieu ideally makes it also for students obvious what are more general, more better answers than others. So in an ideal case, the optimal solution is the solution you want to strive for in the milieu. And then of course it's important for the teacher again to create an atmosphere where this can be done. Mistakes are allowed, and the formulation and validation phase is really an important aspect of each other to understand that this is the way to come to the knowledge you strive for. So we have the institutionalized knowledge. The teacher tries to create this milieu, and during the work of the students there is these phases makes it sure that the students have the opportunity to create their strategies. The strategies are formulated and validated, and in the end the teacher is responsible for institutionalizing the knowledge that we derive from it. So what did we learn from it? Writes it on the blackboard or shares it with everybody, and comes to learning of this the target knowledge you aim for, and make sure that it is institutionalized. Yeah. Did I say it so well? Well, can be better, but there is a lot of theory about it. And what I did now is to contrast it, to see the difference or the similarities with what we did in the previous project, where we had IBL and also inquiry-based lessons, And Malcolm Swan, he came with this structure where the importance is that you introduce something, students explore, then there is a kind of moment where you have process feedback, students continue, then you have presentations, and then you have a kind of reflection. And when you compare it with TDS, there are similarities more or less. Guy Bourgeot is the founder, so there you can find references. He says, well, first important is to articulate what is the target knowledge you aim for, create a kind of introduction where you are responsible for devolution. So that means that you are responsible for students becoming owner of the problem within the milieu, that they can then go into this action phase where they deal with the problem, are working on it, which is didactical. There is a phase of formulation and of validation, and in the end of institutionalization of the target knowledge. So we use this model to design scenarios for lessons, and I give one example of it. Was about enlargement, and the target knowledge was whenever all sides lengths of a polygon are enlarged by a certain factor k, then the area of the polygon is enlarged by the factor k squared. That was the target knowledge, and what we described in the scenarios, that you can start with a picture of buildings, where the buildings have a kind of polygon area on the picture, and then provide different versions of the same picture with different enlargement factors, and let students work on it and to see to what extent they can find what's going on there. And what we found is that teachers in this devolution phase, for students becoming owner of the problem, made different choices. So there was one teacher who gave all the different pictures with different enlargement factors of, so the different pictures to the students to let them do the measurement and see whether they could find what happened with the area. Well, there was another teacher who said, well, so we have this problem of this polygon. Here you have grid paper. Try to find out what's going on with the area when you enlarge polygons. And with these two versions of the problem, you see different things happen. So this is what happened with, for instance, with the teacher that gave the students the grid paper and let them do the measurement. What you see is that they had to generate examples by themselves, had to choose whether it was good to use squares. With squares you can see it easily, that when it's 2 times, then the area is 4 times. And then they try to have a look whether with the triangles, with easy chosen numbers, they could find something similar. While with the other part that looked quite similar, what the teacher did there, with the pictures, here you see the different pictures. They measured the sides of this picture. Here it were pyramids, but on the picture it was triangles. So what the students did was sketching the triangles, measuring the lengths in the picture. So then you get these numbers 8, 8.3, 10.2, and then doing the calculation with, of the area of a triangle and find the areas. But for them it was much more difficult to see a pattern, because you get very complicated numbers, and you don't see that with doubling, and also with different kinds of enlargement factors, not easy, like 2 times bigger. And so here I think, although students, the teacher was happy about what the students did and that they worked nicely, the teacher said, well, but it was much more difficult for them to find out some kind of result. And so what you see, it's really, well, carefully you need to choose what kind of environment, what you give to students and what you don't give, to let them become owner of the inquiry and to let them be able to find something. Okay, so we did workshops, and here you see in one of the workshops Rogier working with teachers, and we let them also work on the scenarios, how to how to let them understand the main idea of the scenarios. We got different kinds of feedback, so I like to try out, but I need to be convinced it's worth the time. We appreciate IBL, and But also the scenarios were such a long read and took quite some time. So, well, different kinds of reactions of the teachers. Good. So TDS and RME helped to become explicit about goals and to make learning visible. But designing the scenarios and implementing the IBMT was rather complex. So we worked with 4 countries and we developed 5 scenarios in 3 years. And so you could say that shows how complicated it is to come to, well, ways of trying to implement it. But still, it helped, it functioned, and it was able to integrate these lessons, but integrate it in their daily practice to learn from it, how to apply similar kind of behavior on other tasks that you use from the textbook was not easy and still a long way to go. Okay, so short reflection on Mastiff. You could say we had a weak effect of a professional development course on teachers' beliefs, and with Miria we had some positive experience, but becoming a skilled IBL designer or IBL teacher requires time and experience. Good. Okay, now we come to the nice part, I think, the reflection on what this means for IBL. First, some other studies. We have this thing of what works. It is very popular in the United States and also becoming more popular in the Netherlands. NRO, the National Research Organization. No, well, NRO, how do you translate it in English? National Research Foundation for Education. Yeah. Also as a what works. And PISA also asked students to what extent the students experience their teaching as teacher-directed or student-directed. And in the 2015 study of PISA, you found some contradictory findings that teachers frequently explain and demonstrate ideas that the students scored higher and have stronger beliefs in the value of scientific inquiry than where there was less reported explanations by the teachers. So this is based on how students report their teaching. And so the performance was lower when it was more student-centered, and also the beliefs. But there can be many reasons for it, and you can speculate a lot about it. But more important, I think, I'll return to that later, is the PISA 2018, one of the 2018 results. So in the NRO, you can find rather often that they don't advocate inquiry, but they advocate direct instruction, and that direct instruction is effective in various domains. And this is what Stockard found. And it's a review study with including many reports. They say we don't include scientific papers, but we include reports. They include many reports where there was some kind of evaluation of direct instruction. And direct instruction has proven to be really effective. So we need to learn from that it's a proven method, it works. But when you read in it, what kind of reports? Well, first of all, it's, maybe we shouldn't laugh at it, but the Stockard and others, they are a member of the National Institute of Direct Instruction in the United States. And they also have their own journal, and they included many reports from their own journal. And that's, okay, so that's not very strong, but sometimes we sometimes also do. So don't critique it too much. But also it was, at least for me, not very clear what was the outcome measure where they performed better. I challenge others to read it and to try to find it out, because I couldn't find it. So it seemed as if direct instruction is effective on a kind of intended outcome measure. So when you really teach to that outcome measure, then they perform better. And there was no comparison with specific other domains. So these are a few critiques on that one. On this one is on the PISA, You can also have a finding contrasted with a finding in the PISA 2018 that they included the question for students. You're related to this growth mindset fashion. So your intelligence is something about you that you can't change very much. Well, in general, we know that in PISA, the Netherlands is really well scoring and on the top, and at least for mathematics. No, for science, I'm reading a bit less, but in mathematics. But what do you expect here for the Netherlands? What would the Dutch students think about their? Is intelligence something fixed, or is it something that can be changed? Changed? You think fixed?
I think the students will think it's fixed.
Yeah.
I don't agree.
So this is a long list from, so this is the percentage disagree. And Estonia, they are on top, Denmark, and then this list goes very long here, and then it goes up here, and then here below Bosnia and Herzegovina, we get the Netherlands, just above Qatar. And that's really worrying, I think, that the Dutch students really think it can be it can't be changed. And especially the blue areas also give, so A is for girls, so there's no difference between girls and boys, but there is a difference in particular between advantaged and disadvantaged students. So probably the disadvantaged think, I guess, that it can't be changed, I'm not sure. And also on the immigrant and non-immigrant students. And so this is a kind of result, I think, in the Dutch system, the differentiation that we do already very early, on early age, 12 years, that makes, I'm not sure where it comes from, but that students have this idea that intelligence can't be changed. I think it's really what we should take serious. And
but what do we understand by intelligence?
yeah, of course, that I think IQ, yeah, I think what they are able to do. Yeah. It's also questionable, but still, I think it's also worrying. Good. Another review study that was really that is quite positive on inquiry-based learning is by Furtak. They included many studies and looked at the effect in different kind of domains. And so here are the domains: procedural, that's mainly performing the inquiry; epistemic is the nature of science, so this is science and mathematics; conceptual, and also social. And what they found is that especially in domains related to this epistemic part, the nature of science, inquiry-based approaches have a large effect. And they also compared studies on the degree of inquiry, so to what extent it's very student-led or very teacher-guided inquiry. And here you see the effect sizes, and in the studies where there was a comparison between student versus teachers-led reform, there they didn't find almost any effect. While the biggest effects were found where you had a kind of teacher-guided inquiry-based learning reform versus traditional. So what the study shows is that inquiry-based learning has a large effect on this epistemic domain, and in particular when it's a teacher-guided form of inquiry-based learning. Another, which I like by Gormley, is where they looked at undergraduate students in their university. So this is not a review study. And what they found with reform that they had in their undergraduate, that student science literacy and research skills improved, but lower gain in self-confidence in scientific abilities. So the inquiry-based students improved their skills more than the traditionally taught, but the self-confidence was lower than the traditionally taught. And so what they say, by maybe due to experiencing the complexity of and frustrations made them become rather critical of their own ability, while the other ones didn't meet any frustration. So they probably overestimated their ability in inquiry, but that's also a bit speculative. Okay, some other studies as well by Joe Bowler, the importance of growth mindsets and learning from mistakes. And Lazonder and Harmsendale had a review study where they looked at different kinds of guidance, because that is what we didn't look at before with the other review studies. And so they looked at the differences from very specific, where you give explanations of how you should do it, to almost not explicit, where you only give some constraints about the processes that can be or are not allowed, are allowed or are not allowed. And there are some differences, so status overviews, where are you, prompts that you remind to give some action, or you give really heuristics how to do it, or you provide scaffolds. So they looked whether these different types of support had any differences in effect on what the students learned. And they found that, well, in general, guidance has an impact on development of inquiry skills, more than an effect on domain knowledge. The hypothesis derived from Kirchner that young children need more specific guidance because they are not able to self-regulate and to do things by themselves, while others, more experienced students, don't need that, this hypothesis. But that was not confirmed by the study. They found that even with young children, you don't need very specific guidance. They need guidance, but the specificity is not really an important. And so they said there needs to be guidance, but not necessarily specific. And that's what they found in the reviews. Good, so that is what other studies, well, I summarized and thought is important to share. So what, to conclude, in inquiry-based learning, what we've seen, we try to aim at a deeper kind of learning. One characteristic, it's learning from struggle instead of having students try to copy behavior and reproduce procedures. The importance is that you let students become owner of what's going on. And you change the didactical contract. That's also what in TDS we try to do. And you value these inquiry processes and nature of science also as part of what you aim for. But in the implementation, well, so that doesn't mean that you have open problems and unguided situations, but you need structured lessons with adequate guidance for students, and you need to align all these resources with the teaching and the feedback that you give during the teaching towards aims that you share with each other, that everybody understands where you're going to. Try to create kind of zones of proximal development. That's this milieu where the students act on their own and are able to act on their own. Carefully choose the guidance and reflect, institutionalize, take that phase serious. That was really helpful in this Meria project, that the teachers knew that that was some part of the lesson need to be secured, saved for institutionalizing, reflecting on what is learned from this inquiry activity. So why, despite of all these positive or weak effects, did it not work? Well, in my opinion, one of the reasons is that we frame IBL as a kind of student-centered approach with minimal guidance. And we don't, of course we don't, although what we do report of often is the importance of the unguided, of the activity of the students, and that there is an unguided phase. But still, and I think we failed in emphasizing the importance of the guidance around it. And we know that IBL asked for carefully chosen guidance, but I think we should have emphasized that more.
So are you talking about Meria?
No, I'm talking now in general.
Because the first part was quite positive.
Yeah, so yeah, that's with our results, but in general, I think we failed and we were not able to report well enough the importance of the guidance. In general, I think so. It must if we were able, but it must if was part of a professional development course. And when you talk about so general understanding of IBL and general take up of IBL, there you don't have this situation where you have a very focused course, so you are not able to really emphasize the importance of guidance and give tools how to guide.
Okay, so you're talking about the whole research field
Yeah.
in the whole world.
Yeah.
Okay,
Yeah.
thanks.
Yeah, yeah, good remark. Yeah.
Or do you mean the public debate about this? I mean, we're losing the debate about teaching to people who promote direct instruction. And is that what you mean?
Yeah, well,
And of course, I mean,
Yeah.
those the research data are just part of that. But okay, but then you were working with these teachers and so on, and it is.
yeah, I think we managed within the projects with the teachers with who we have worked to make a change, make a difference. But I think in the general debate, in the general discussion, it's really difficult, and there we more or less failed, I think. I'm not sure, but that's what I see happening around.
Sure.
See schools, teachers choosing for textbooks that really make it almost impossible to implement inquiry-based teaching. And I see movements towards the importance of procedures and algorithms and not deep understanding and inquiry skills.
Yes, their
Yeah.
theory of teaching is
Yeah.
easier, is more convincing than ours, I think.
Yeah. Yeah. Okay. Well, I'll make the list of points, and I have some points for discussion as well. I think also a problem is that, and that sometimes I myself also notice that I say, yeah, compared to traditional, or while I think it's not an alternative, because it's impossible to do only inquiry-based learning in your classroom. You need also practice, you need other ways of sometimes tell a nice story about some topic that you know you can tell a good story about, and that you are allowed to do, of course, as a teacher. So it's an enrichment of teaching repertoire, we try to emphasize that always, and not an alternative for traditional teaching. So I think there we also, I'm not sure if I need to talk about we, but we could have done better there. Then, problematic is that direct instruction on specific outcome measure outperforms alternatives. Yeah, again, maybe I shouldn't have used alternatives, but that can have multiple outcome measures. So often when you want to stress the importance of inquiry, you're not talking about one specific outcome measure, but it's often more rich what you want to achieve. Outcome measures in general hardly changed all over the world. I think we still try evaluating our students in more or less the same way as 50 years ago, well, 20 years ago at least. And that's also based on my experience at least, that changing and extending your teaching repertoire, and also that's not only about the teaching, but also the designing the education material for that can be used in inquiry, needs time and support. It's really a time-consuming approach that needs much more time to design the materials and to prepare your lessons than in your traditional practice. So it also asks for specific resources and teaching skills, and you could say that in direct instruction, transferring your knowledge that is summarized in the textbook to students, it's much more easy than identifying opportunities in student work and building on their contributions while they work on open tasks. So showing more or less the difficulty and the difference between the two views on teaching. Yeah, so for discussion, how do we conceptualize IBL? So Jan de Lange had in our summer school a talk also about more or less inquiry-based teaching, and he said, well, only do it when you believe in it. It's not something for all. So we could discuss about it. Is it some way of dealing with education for all, or is it only for those teachers that really believe in it? What should we do with teacher education and professional development? Can we expect that all teachers, so when it works with Mastiff project, when we were successful, does that imply that we expect all teachers to be involved in these kind of professional development courses? We cannot force them. To what extent do we acknowledge diversity? Do we really see it as an issue? And do we really understand that we need to take it into account and to design our materials and to look at classrooms in to what extent are they inclusive? To what extent do we really emphasize students that they can learn when they practice, do their best, and don't label too quickly? So now we have the discussion about the middle school again. So how is our position there? On the one hand, I already hear on Twitter, but you cannot expect that VMBO students are together with VWO students because the good ones are not challenged well enough, and the other ones always have then the lower grades, and that labels them. But on the other hand, we are labeling them now. Okay, so what kind of evidence do we have? So we found some evidence, but is it convincing enough? Do we have an alternative for what works? Did we post anything there, or how to push NRO? Because there it's really full of direct instruction. And who decides where we aim for? That's also nice. That I think 10, 20 years ago, an institution like ours, subject didacticians were really involved in curriculum development. Well, we now more or less are more on the side, and it's in the hands of educational scientists or further education that says, well, this is what we want the students to be able to do, to learn, and so they determine the what, and we are not there anymore. So these are questions I think that are important for us and to take account of. And this was the end of the talk. So thank you for listening so long.